Howdy 7th grade. Today we're talking about one extra bit of vocabulary we're going to add, and that's about it. So it should be a pretty quick video. What we're going to talk about today is this thing called slant height. And slant height is something that we can talk about when we're talking about either cones or pyramids, and it's just a different part of the cone or pyramid that we didn't have a name for yet. So I'm going to start off by drawing a cone here. I know that I draw terrible cones, but you know, we have a good imagination, so it'll work out. So if I have a cone, what the height is, I hope we know, is the distance from the top down to the base. That right there is going to be my height. So the difference between height and slant height is that height assumes I can go straight down this pyramid, or this cone. For slant height, we're not going to make that assumption. We're going to basically say we're going to pretend we're on top of our cone. So I'll draw another one right here. We are on top of the cone, and we want to know, if I went to run down the side, what is the shortest distance it would take me to get to the bottom? So it's how far is it from here down to there? That distance is going to be my slant height. And that's mostly what we're talking about today. So the way we're going to find our slant height is with the Pythagorean theorem. So we're going to find with Pythagorean theorem. And the reason we're going to do that is going to become obvious in just a second. So if I take a cone and I cut it down the middle, it would end up looking like a triangle. So you're going to have to imagine that there's part coming out this way and part behind it that way. But really, our poor cone here, we just cut in half, and this is all we can see. So if I know the height, and let's say that the height is 5, and my radius here is going to be, oh, let's make this 10. That doesn't look right. Let's make our radius be 4. That way it looks about right. So my radius from here to here is 4. My height from here to here is 5. My slant height is going to be this last side. So this is my slant height. And the way I'd want to find this is the last side of a right triangle. It's going to be Pythagorean's theorem. So I would start with a squared plus b squared equals c squared, or Pythagorean's theorem, and I'm going to plug it in. So know that c is going to be my long side, which is my slant height, and I don't know what that is. So I'm just going to leave it as a variable. I do have these two other numbers, and they're on my short sides. So that's going to be one is a and the other is b. That's 4 and 5. Doesn't really matter what order I put it in. So I have 4 squared plus 5 squared is going to equal c squared. 4 squared is going to be 16. 5 squared is 25 equals c squared. And 16 plus 25, I'll do that real quick, is 41. Gives me c squared. So I'd end up with the square root of 41 equals c. Which I know isn't a very pretty answer there, but it's the one we got, so that's okay. And that's pretty much how we're going to find it. Quick note, we can also find slant height in pyramids. So if I have a square pyramid, let me write pyramids real quick. If I have a square pyramid here, where it comes up to a point, and it's an ugly looking pyramid if I have ever seen one. There we go. It's a little better. The slant height is going to be still the distance from here to the bottom along one of the sides. And it's going to be the shortest distance, so it's going to be right down the middle of one of these triangles. So what that means is there's going to be a few different ways to find it. Really, we're going to use the same way as we did with the cone. So we're going to cut it in half, and we're going to use Pythagorean's theorem. So real quick, if I drew this as a net, just so we can see what's going on a little bit better. So drawing out the net of my pyramid here, I'd have my square base with my triangles. My slant height would be, that last one was an awful triangle. Right there, okay. So my slant height would be the distance from the top of my pyramid, which is going to be right here, down to the base, which would be right here. So that right there would be the slant height. Which is also this distance right here, the slant height. So once more, if I took my pyramid and I cut it in half, so you'd have to imagine normally that there would be a bit coming out here and out there, and this is what it would actually look like. But we're just cutting it in half, and we're looking at what's called a cross section, if I have my base here, and my base is 10 or so, and I know that my height is, I'm actually going to make the numbers a little easy. The height's going to be 3, and this side's not going to be 10. This is going to be 8. So let's erase that. If I want to figure out what my slant height is here, I'm just going to do this. My slant height. I'm going to use Pythagorean's theorem again. I know that this distance here is going to be half of 8, which is 4. So my real triangle would be a 4 and a 3. Don't know what this is. So I would have that 3 squared plus 4 squared equals my slant height squared, which is c squared. I'd get 9 plus 16 equals c squared. 25 equals c squared. 5 equals c. After taking the square root of 25. So my slant height here would be 5, and that would be all I need to find. That's pretty much it. So all we did today was learn one new vocab word, which was on slant height, and we should be all good to go. I hope we all have a delightful day. I'll see you all tomorrow.